welcome to the last ECE 420 class of the semester. Yay! The cloud is wild. Oh, isn't this exciting? Today, I'm happy to report that the network is completely down as far as my computer is concerned. What this means to you is that if you want your files on this machine, you will have to put them onto a USB key. Who here does not have a USB key for their files? Be honest now. Okay, then it so happens I have a USB key. Oh, and you don't have the files either? You mean you have the files uploaded to Axiom?
Yes.
Which requires that you have network access. Perhaps your colleagues could help you by using their computers. Or I could use one of my computers, which actually does have network access, and download all the files all at once and put them on this key. And that might be the way to go. All right, so what we'll do while Alfredo here is doing his presentation is I'll do the download from Axiom, and then in theory we'll have everybody's file on one little key. That might be a good way to go, actually. I like that. Okay, we'll do that. Let's see what we can do here. So, Alfredo, you have a printout for me? Alrighty then. Let's get you going. You are up. And I will attempt to do a download. Thank you.
Good afternoon. Today I'm going to talk about active noise cancellation by mechanical scanning sonar. My previous design was in a leaf blower, but now with this new concept I'm going to cover closed environments. That also is included the leaf blower. My outline is the same: the overview, the active noise cancellation, problem statement, approach to solve the problem, the execution, project demonstration, and my conclusion. Now, active noise cancellation is when we have a primary source, in this case is noise, and we are going to use a secondary source that are speakers. And when the sound waves are together, the result is the cancellation of noise. But now what I'm going to add in my new design. In my new design I'm going to have a 3D scanner. This 3D scanner is going to take all the dimensions of a closed environment, and with the use of algorithms the computer is going to analyze the environment and is going to put together the best options. In this case, looking for the best location for my microphones and also for the best locations for my speakers. I did my research, and one of the companies that I'm thinking to get the equipment is Blueview. My problem statement is the reduction of noise levels. There are such environments where there are workers that are exposed to high level of noise, and there are some hazards, for example hearing loss. Another problem statement is the passive noise reduction systems. Passive noise reduction systems are, for example, material that we have to use in order to reduce noise. But this is a problem because there are some places where we can place these devices, and also it's very costly. It's more expensive to do because for the materials. This is my approach. This is gonna be my prototype. I'm going to use my 3D sonar scanner. I'm going to get all the measurements, in this case for this conduit. With all the measurements, the program is going to tell me where I'm going to locate my microphones and my speakers. Here's, for example, in the picture I have the primary noise. We have three arrows, and after my noise cancellation, I'm going to have only one. That means that my goal is to reduce the noise. I have different approaches for my motivation. The most important is that is unlimited useful applications. For example, we can use this application in environments like factories, where we can apply noise cancellation for workers. For example, people who work in the field with big motors, active noise cancellation is going to work. Where I'm going to reduce and improve health for conditions where noise can be an hazard. Um, Another important thing about noise cancellation is all the machines are gonna be more efficient. Vibration is gonna be reduced. My social impacts, I have ethics and my safety. In my ethics is I want to improve environment for workers. But the downside is my applications could be applied for military applications. For example, if we have tanks with active noise cancellation, we can reduce or eliminate the noise produced by big guns. For my safety issue, uh, my active noise controller could be an hazard because it could be overheat. So I need to be very conscious to have some precautions. In this case, I want to install a temperature sensor that is going to avoid this problem. Also, my device could start a fire, so that's why I want to I want to take all the precautions in order to have all these problems. My advantage is with my designs I don't have a competition. There are devices for active noise cancellation, but in my case, I am working with closed environments and using sonar technology. My algorithms are unique, and I am going to fusion different technologies in one. Oh, I'm going to have a market. My market is going to be focused in consumer goods, most important in power plants, factories, offices, where there is a lot of high level of noise. I'm looking at profit for 60% margin. For my agenda, I divided my designs in 4 milestones. The first one is to to achieve my algorithms for the mecha. Yes,
Yeah, can you go back a slide?
yes.
If you know that you're going for 60% profit margin, how much does it cost?
The design,
Well, no, I got that there's a profit on some sort of a product.
right?
So how much is the product?
My product costs 10,000.
Your product costs
$10,000. Yes,
per unit,
per unit. Yes.
and this is for a leaf blower.
No, this is gonna be for closed environments. So I'm going. My active noise cancellation is going to work for closed environments with the use of a mechanical scanning sonar.
Can you please explain what happened to the leaf blower?
The big, the big, the leaf blower is just one
The
extension.
leaf blower was just last week,
Yes,
but
yes.
this week it's different.
This week is an improvement of last week
Oh,
because in last week the leaf blower was a small extension of what can I do with active noise cancellation. If I take in a bigger scale for using active noise cancellation by closed environments, the leaf blower is just one part of the picture.
okay. How did you decide to abandon the leaf blower and go to the big picture thing?
I didn't abandon the big blower. The leaf blower is a small fraction of the overall picture that I have. the leaf blower is still in this format. With the same application, it's going to be applied for the leaf blower.
Well, don't you think a mechanical scanning sonar system is a rather different set of problems associated with a simple leaf blower?
But for example, for the leaf blower, I need to know the dimensions of a leaf blower. But with the mechanical scanning sonar, I'm going to know the dimensions of the leaf blower, and plus the algorithm is going to help me to figure it out where I have to put the locations for the microphones and the speakers.
So is this a system to design an active noise cancellation systems, or is this a system for active noise cancellation?
This is a system for the active noise cancellation.
Okay, I'm sorry for interrupting.
No, it's alright.
We have a discussion about this offline.
Okay.
Thank you.
My market. This is my agenda. My agenda is divided in 4 milestones. The first one is the algorithms, in other words, the software. The second part is my hardware. The next part is the system integration between the software and the hardware, and my marketing. This is my Gantt chart. I have divided in 10 steps: in software development and testing, looking materials, test materials, and system integration and simulations, and my prototype and advertising. Looking all the steps, my main goal is to have a prototype. With my prototype, I can advertise my product in Kickstarter. These are my results. My acoustic, the top figure shows the primary source, in this case the noise, and the second, the lower picture shows a secondary source. In other words, the results that I'm going to get with the speakers. Making my project, doing some tests, I found that in this case 3 speakers has a better efficiency in my design. But on the other side, I have the heat is increased with the number of speakers. For my conclusion, I can say that in my project, active noise cancellation is possible, and with the results, closed environments, it's possible to create active noise cancellation in closed environments. The future goal that I can see is that we can have more. I can improve my computation time for the algorithms, and also have to improve or add something extra for heat dissipation in my active noise controller. Thank you. Some questions?
Is it your contention that Kickstarter is going to come up with people who will pay you $10,000 per unit?
Yes. With this design, the Kickstarter is gonna be my start for my company, I can say.
Have you ever seen a Kickstarter project where people pay $10,000 per unit?
Yes.
What would be an example?
An example is I saw a device that is something like a PS3 or an Xbox that is online, but you can interact using accessories, like for example the Wii, something that you can play that you can use with your hands. There's something online in Kickstarter that I think they were looking for 30,000 or 40,000, and they got it.
40,000 was the total for the project,
Yes.
but it wasn't the price per unit.
The price per,
Price of the unit was much less than 30,000, wasn't it?
the price per unit was maybe $500 around.
Right, $500. But you're asking $10,000 per unit.
Yes, but this unit is not gonna be just for. I am my market is not individuals. My market are companies. Like for example, a company that makes leaf blowers. I'm gonna present my project. They're gonna give me the dimension of that leaf blower. I'm going to analyze the leaf blower, and I'm gonna predict the locations of how we can improve or reduce the noise. Or for example, in cars, with my 3D scanner, I can scan inside a car and look for the places where I can place the microphones and the speakers in order to do active noise cancellation.
So what will you be offering on Kickstarter?
Or, well, the thing that I want to ask for Kickstarter is money in order to get my fundings in order to accomplish my research.
You want Kickstarter to fund research.
Yes.
I see. So you're not trying to sell anything.
And Kickstarter, no. Well, I need to get my funding with Kickstarter.
Has Kickstarter ever funded research before?
I didn't pay a lot of attention if Kickstarter can do that, but I see that, for example, Kickstarter, they can fund people that they want to, for example, renew a studio for painting, for example.
I've never seen Kickstarter fund research. Maybe if there was a reward involved,
Okay.
they might fund it. For example, if the reward was a quiet leaf blower, and you were going to deliver a quiet leaf blower, that they would fund.
Okay.
Because they want something in return. Kickstarter backers usually want something. You have to deliver.
Okay.
My last Kickstarter project sold over 200 units, and I just took delivery of 400 printed circuit boards from China. I now have to assemble them and deliver them as part of a reward. People pay for things. They want stuff. They don't want ideas.
Well, if in Kickstarter, I I change my concept in Kickstarter, and I made my design, and I put it in the market, and I make my video in Kickstarter, and I offer this package of how you can reduce noise. Is gonna cost 10,000 for any kind of company. Let's say, for example, Ford. Ford, they want to improve active noise cancellation. Okay, I have my package. My package costs 10,000. So the package comes with the software, and you can apply all this infrastructure in your cars. I can try to offer something like that. Or for example, Fairfield University, they have a big auditorium, and they want to apply active noise cancellation for noise. With my package that costs $10,000, they can study and do the simulation of the environment, and they will predict what they need in order to do active noise cancellation.
Okay, well, thank you.
Okay.
Okay, so our next guest of honor. This is very educational. I will not be able to grade your printouts since you didn't print them.
I think I'm like better with the next one do that.
Oh, that's very good. I appreciate that. Thank you.
Hi, good afternoon, everyone. Today is the brief overview of my thesis proposal. Uh, this is the abstract. The basic idea of this thesis proposal is to create a homopolar superconducting motor under driest temperature conditions.
Can you speak up? I'm having a little trouble with the sound in the back of the room. I'm going to sit closer so I can hear. This doesn't make you nervous, does it?
No. So my motivation, under my motivation, there are like 3 items: pain, advantage, sustainable competitive advantage, and market. So what's the pain in this? Why I'm doing this thesis proposal? Like we have motors at 77 K, but I mean liquid nitrogen temperatures that work under liquid nitrogen temperature, but we haven't. Uh, we don't have any availability of motors that work under driest temperatures. That's the pain in it. And advantages, we can have these motors that work at under solid CO2 temperatures. That's the in my guess that's the main advantage of the my thesis proposal. And market, uh, we can have these motors in navy applications like in submarines. Last week, professor, you asked me where these are applications of these motors. We can use these submarines in submarines where the temperature is very cold. So it should be an ultimate market, not the preliminary market. So, and the research agenda, goal is to create a superconducting motor that works under solid CO2 temperature with low size, low cost. And why I mentioned low size is we are operating under solid CO2 temperatures, so we can decrease the size of the coolants that we usually put in all types of motor to reduce the heat flowing from heat coming from the motor. So my contribution till now is like I studied every related work related to the motors that works under that works with superconducting materials, that works with like I have studied the dryers Stirling engine that powered up by using dryers, homopolar motor. I studied everything. That's the contribution of my mm, contribution in this semester. And future work, I need to locate materials. Those are available under CO2 condition. I mean liquid, solid CO2 conditions. I'm going to design. I'm planning to design with this using neodymium magnets. And I'm expecting results like to have a prototype that works under CO2 temperature, the solid CO2 temperature, driest temperatures. I'm going to use superconducting windings for magnets and coil windings, and this should be a super homopolar motor. Societal implications, uh, ethical issues. We we have this. I think this idea should cover the all ethical issues that are under IEEE and patent USPTO. And safety issue, the heat produced by the motor are compensated by the driest environment. So we do have a safety issues. We can eliminate that by using that environment type. And this is my Gantt chart. uh, in my guess, I'm going to complete this project at the end of 17th September. Like I have an overview of that one.
If you use CO2 that's frozen in order to create your low temperature, will that increase the emissions of greenhouse gases like CO2 as the ice sublimes?
No, actually, when the motor works, it produces some heat. So these should be compensated by the driest environment in that.
What does the dry ice melt or gasify and release CO2?
Those are the safety issues we need to consider when designing the motor environment. And these are the references that I have studied. These are the papers.
Can you go back to the Gantt chart? Societal impact.
I mean, study of the societal impact.
I guess the Gantt chart should contain those things that you propose to do. You've already done all of this.
No, I have meant to mention that one. Locating materials, material testing, design of sample.
Okay.
Those
So
are the
the
future
first
works.
half- The first half was done, right?
Yeah,
Done
first
now?
half was done. Like until now, 30th April, final presentation of thesis proposal. After that, we need to locate the materials.
So you're going to finish your thesis in September. Then you'll graduate. Excellent.
Then I'll be graduate.
Well, I'm very happy to work with you all summer. We'll have no trouble. It might get too hot for your motor. Very good.
Thank you.
See if we can get it rolling.
Sporty. You are up.
Hi, my topic is energy monitoring, and this is abstract. This is mainly used to gauge the use of power, and then it monitors all the appliances which consume power and give us the exact amount of the power. And then in the motivation, pain. We don't want to spend thousands of dollars on a more like a refrigerator which is consuming more power, so and we don't know which appliances are consuming more power. So I think it is better if we have any monitor which can helps us to tell like which appliance is using how much. And when I talk about the advantage, there is no such outlet in the market which gives us the exact amount of usage of power, and then usage of power continuously. And then so I think if anyone wants to save money, so they all want to buy this, so I think it also sells better in the market. And then in the research, in the motivation about the ethics, it follows IEEE ethics because it is an electrical. And then about the safety, because it deals with the high volts of temperature power, so we need a kit like so that it will help us to sell it, and even to avoid those all the mishappenings which happens with the high volts of temperature. And then in the research agenda, I read so many papers and then about this. And then finally I need hardware. I'm using Arduino board PC, which Arduino board which helps us to logs the values. And then I'm trying to use internet, Wi-Fi or Zigbee, any of these which helps us to send the values from a outlet to a computer. And then outputs, this is a prototype of a browser app. This is just a prototype, like you asked me last week, like you need a website which tells us the amount. So in this one it tells us if we go for the power, it will tell us each outlet and the power which is consuming and at what time it is consuming. And it will tell us by calculating all the outlets, it will tell us how much cost it will be for this month. And then the next one is the total power. And then the graph, it helps us to keep an eye on all the to keep an eye on the cost we are spending on the power. Like we can see right here, we can just see 2 months of the amount. And this is the Gantt chart. And the first I think I'm almost 90% done with the research proposal, like thesis proposal and research, and then I'll need some time for the collection of the hardware and the implementation of hardware and the software, and then I need to integrate both the hardware and software so that it works effectively, and then finally I'll experiment it, and if it doesn't work, I'll try again. So I need some more time for it, and then the results. Yep.
So who will do the hardware?
I didn't get you.
Well, it says here that you're going to do the hardware design while you write the software.
No,
Are you going to do both at the same time?
what I meant by this is we have to do at the same time, because we need both of them to check whether they're working correctly or not. Like we need software to see whether the hardware is running properly, and we need software to check whether the hardware is, whether we are using hardware properly. So we need both at the same time. So I meant those two, but in that way, like we need
Well,
we
if you
need to do.
both at the same time, why is hardware design finished after software is finished?
Like because with all the circuits and everything, so I thought maybe it will require more time.
Well, I can tell you that I'm doing a hardware project with
Yeah.
software now,
Yeah.
and I did a little software, and then I did the hardware design, then I went back and did some more software,
Yeah.
and then I redid this hardware design, and then I went and did some, we had to redo a lot of software.
Yeah, it
So
depends on both
I go
of.
back and forth
Yeah.
between the two. Right now, I just finished up the software on my final hardware design,
Okay.
but now I'm thinking that there are still some shopping where I'll substitute some components.
Got it.
So I don't want to change the printed circuit board because the holes are already cut. So components can't change that much.
Yeah, yeah.
And so if I shop for different components and they don't fit, then I have to go back to the original
Got it,
components.
yeah.
So there is an integration between hardware and software,
Mhm.
and it's never clear when the hardware is really done. Until
Yeah.
it's all assembled and in the final production run.
Yeah.
So I'm up to, I guess, the third revision on my hardware boards.
Yeah, I think we need more time on those two. Like the implementation should be according to those two. So
Yeah,
I put.
prototyping is something that we need to do in several iterations, and these prototypes, these are all after the Kickstarter project has been done.
Okay.
So I had a version 1.0 of my board, and that's what sold.
Uh-huh.
And version 3.0 of the board, which represented two major spins later.
Okay.
So it's difficult when you go into production.
Got it.
Hardware and software integration, experimental results. Are you going to write?
I.
Because you should have a section here about writing some things up.
Yeah,
Perhaps
I
you
will.
you
I will
write
do
it
in
somewhere.
between. Like, I'll do the outline and everything. I'll add it in the end about the thesis and.
We'll do all the writing at the end. All
Uh,
right. Well, you've done some writing in the beginning. That's good.
Yeah,
Now
yeah.
You have a framework upon which you can use.
Yeah.
Okay. 90% done.
I think it's 90% done. I don't know, but I just wrote it like that. So because we're almost
Software,
end. So
I think software needs to take more time.
okay.
Your software is very optimistic.
Yeah,
I
yeah.
think so. But maybe I'm wrong. You could be very good at software.
No. Yeah, yeah.
Okay.
I'll need more time for that. Yeah.
Probably. Well, you've got a separate thing called software hardware integration. You may be doing more software development there.
Yeah.
Okay. What else?
That's it. Yeah, the browser and this. That's it. Yeah.
Thank you. I would say you probably need a separate slide on ethics and safety.
Oh, okay.
You know, you just sort of steamrollered over it. Chitan, you are up.
So even without a network, we're doing okay with this. I think. We just have to take notes.
My thesis proposal is on calculating maximum power point tracking. So this paper presents an efficient method to calculate maximum power point tracking. Usually the present systems runs on TSR method control, and I'm combining this TSR method with Hysteresis, which improves the dynamic characteristics of the complete system. uh, Motivation why I'm doing this, it's MPPT calculation is one of the efficient way to improve the efficiency of the wind systems. um, Most of the present wind systems are operated by this TSR control, and but TSR control unit can be still made dynamically improved by combining this Hysteresis method. Hysteresis method works with, yeah.
You don't mean to be picky, but you've done this before. Hysteresis.
Oh, Hysteresis.
It's hysteresis.
Okay.
Do you know what hysteresis
Yeah.
is?
That's advantage of this. TSR methods get uses data from sensors, so which is I can say like it's dependent on other system like sensor systems. With high speeds they don't work, or they lose sensitivity, which can generate inaccurate data, which causes to down of the efficiency of system. With combining with this hysteresis method, it comes independent of the data, so which can still maintain the efficiency of the system. Coming to the market, from first maybe just to upgrade the present running wind systems. um, if it works, I can improve this to this can be applied to domestic wind systems. Approach, depending upon calculating the system characteristics, I'll put an optimal value for the wind change, and if the wind speed change is less than the optimal value, normal TSR method works, and the wind speed change is more than the optimal value, this Hysteresis method comes under operation. Coming to the ethical view, it comes under MITRE comes under utilitarianism. By making it more efficiency, energy generation can be improved, and can get at a lower cost, so making happiness and reducing suffering. Safety issues, so we are dealing with the power instruments, so installation precautions should be necessary, should be taken, and as of we are this wind towers are high, and climbing should they are risky, so should take care of those. My research agenda is studying of different MPPT calculation methods and its dynamic characteristics of each method. So my thing is to experiment this TSR operated units with combining with these hysteresis, whether they work out or they come out with a positive output. This is my Gantt chart. I did something. I can say it's not completely well presented, but I need some small changes, like software implementation. I didn't put that. I don't know. This is my Gantt chart as of now.
So, it says here the concept design is done after the research.
Yeah, research. I mean research. What I mean research is that studying different MPT methods, like studying patents, paperworks.
So the whole thing results in a simulation.
Yeah.
And then after the simulation, you gather data on the simulation. And it's that data that validates your hypothesis. So doesn't validation come after simulation? Because if you've already
Yeah.
validated the idea, then why do the simulation?
Maybe I should correct it
I
as.
think they're flipping, right?
Yeah.
First you simulate,
Yeah.
and you gather data, and that hopefully validates your hypothesis.
Yeah.
Now, if you want to further validate the hypothesis, you might actually build a small prototype
Prototype.
with variable pitch
fan blades that you control with your little microcontroller-based algorithm. And then you can put it up in our little wind tunnel and change the wind speeds, because we have one next door, you know. And you build a scale model. And then that prototype allows you to further validate by experiment your hypothesis of how things work. But I have a basic question. What software does this kind of simulation?
So because it's a control unit, maybe like normal assembly language, or
Don't you write it in assembler?
I mean,
Really? You mean like 8-bit toaster controller or
not like that.
What are you simulating? Are you simulating
The control unit.
system? And are you going to simulate the control system by building it? Is this a prototype? Is that what you mean by simulation? Or are you going to simulate it in the computer?
Computer.
So are you simulating computational fluid dynamics?
No, I mean I'm simulating the control unit. Like I'll implement the software that I wrote for the control unit, like switching from TSR mode to hysteresis mode.
Suppose you simulate the control unit. Then what? What does the control unit control? Does it control simulated fan blades?
No. It simulates hysteresis method.
I don't understand what you mean by simulation.
Uh,
Can you explain what simulation means?
I'm
How do you
just
simulate?
experimenting my idea using the system, computer.
So you use a computer.
Yeah,
Are you going to use a microcontroller?
I know.
Okay. So you're going to simulate the microcontroller in the computer?
Yeah,
Okay. And you're going to simulate your algorithm that runs on the microcontroller.
yeah,
And then you're going to simulate the action of the fan blades as they are reacting to wind.
yeah,
And so the wind is like a fluid.
yeah,
And so you're simulating the computational fluid dynamics inside the computer.
yeah.
Okay. So now, go back to my original question. What software allows you to simulate computational fluid dynamics inside the
I'm
computer with a control system?
Even I don't have. I'm searching for it. Like I'm searching for it. I
Okay,
don't
you
know.
don't know.
Yeah,
I don't know is a valid answer, but we'll need to know
Yeah.
before you go off and start simulating.
yeah,
Because something is going to have to, I mean, you might say, oh, Nastran can do it. I know how to use Nastran. And I'd say, great, okay.
yeah. I searched for a couple of simulation software, but they are like
Does Simulink do this with a toolbox from MATLAB? I don't know. You tell
No.
me. Your research.
okay.
I mean, something can simulate computational fluid dynamics.
Yeah, search for
People simulate helicopters
yeah.
before they build them.
Yeah, but I searched like a couple of simulation softwares are on the internet, but they are like for industrial purpose. They're like very costly.
Well, maybe they can give you a discount with your education. All right, so simulation software. So you're actually just going to simulate the whole thing, and you're not going to build anything.
No.
Okay,
Yeah.
so you really don't need to simulate the microcontroller. You just need to simulate the algorithm that you
That-
would implement in the
yes.
microcontroller. Okay. Fair enough. And it's a big difference, right?
Yeah.
Because if I had to simulate the microcontroller, I would really. And then you say, I'm going to simulate it using assembler, and I might say, hold, let's not do that. We actually have simulation software somewhere. I think we have Simulink, but I don't know if we have it here. Yeah, not here. But I certainly have microcontroller stuff. George is not here. Raul, I think you're up. Okay.
Good afternoon, everyone. My topic is wireless transmission of power using the frac plant NAS. So, coming to the research agenda, and the first point is like the goal. So, my goal is to transmit the power wirelessly this Vitricity has been done before, but there was no research done for transmitting the power wireless using the fractal antennas. So recently there was a Sierpinski microstrip fractal antenna that has been used for transmitting the power, but the efficiency is like very low, which is 50%. So I was trying to increase the efficiency. That's how my approach, my goal is different from that of the previous researchers. As I was talking about the difference, so the previous researchers used the very low frequency, but I choose to use higher frequencies because the reason for using the higher frequencies is that at high frequency the gain and directivity of the transmitting antenna increases, and also the power required for the transmission becomes low. So it ultimately results in very good performance and efficiency. So I thought we can use high frequencies for achieving the higher efficient antennas. And coming to the analyzing of the result, I searched in the internet, but I couldn't find any software that can analyze the data and give out the efficiency. So I think the only way that we can analyze the result is that we need to fabricate the antenna. We need to test it at like different frequencies, then calculate the efficiency at every frequency, and then choose the frequency at which the antenna delivers the higher efficiency. So it's kind of a big process, but I think this is the only way that we can analyze the result.
Basic question. Is there any software available for simulating antennas?
Yes, for simulating the antennas there is software, but I looked at the I looked at the abstract of the software, like what the software does, but I couldn't find the software where we can change the frequency and get the output um, at different frequencies of the antenna. Like if we change the frequency, I couldn't monitor the output at every frequency.
Are you able
So-
to monitor the output at a given frequency?
No, there isn't any column to set the frequency in the
You
software.
can't change the frequency
In the
input to the antenna?
Yeah, in the software, yes.
How about like use Spice?
So what is it?
Spice is an analog simulator. I think you can change frequencies in Spice.
I didn't come across with that.
Yeah, you should look at Spice.
Okay. SPI is
SPICE. Ask Dr. London.
okay.
He can help you with this.
Okay. And coming to the the things what I have done till now, this is the Gantt chart. So I couldn't get the Microsoft project, so I did with the using the Microsoft Word itself. I got the idea of how the Gantt chart should look like, so I did it myself.
So the last milestone is how to validate and analyze results.
Yes.
Maybe it should be to analyze and validate results.
I mean, as I told you that I couldn't get any software, so I thought the ultimate way is to design, fabricate, and test it.
Okay.
So I thought it would be like how.
I'm just sort of criticizing how you wrote this.
Okay, yeah, I will change it. I will
That
change
needs to be sort of made assertive.
it. Okay, I will change it.
Instead of how to, it should just say
Validating and
analyze results.
analyze it. Okay.
Validate hypothesis or
Okay.
analyze results and select. instead of choosing, select best approach.
Okay.
Just make
Okay.
it simple.
Yes. Yes. Sure. I will change the terms.
If you're going to spend time reviewing papers, you already did that this semester.
Yes,
So that's,
yes.
already been done.
Okay. Yeah.
Okay. Thank you.
And
Oh,
as
there's more.
yeah. So coming to the like the motivation for the first point is like the pain. So I would like to the main aim of the project is but that because of using the wires there may be in some unexpected dangerous situations caused. So like for example the short circuit or fire accidents which may lead to loss of life. So in order to reduce the unexpected dangerous situations caused when using the wires to transmit the power, I think we can use this Vitricity concept and I mean it would be very advantageous. And also at the like the all the wires are like hung up at the top of the pole, so it might be like a difficult job for anyone at the time of maintenance or the time of repairing the wires. So even at these situations it would be very this Vitricity concept would be very useful. Yeah.
If you go back to pain, yeah, I say batteries always run out. And with
Yes,
Vitricity,
yes.
the batteries will never run out.
Yes.
You'll have like maybe a supercapacitor.
Yes.
You have some proximity to some
The battery
electricity
automatically
source,
charges when it is
and
in
then
the yeah.
you're always able to run.
Yes, yes. Yeah. I wrote the point in the paper, but this just is just some points on the pain, no, not completely.
Well, I love the idea
Yeah.
of never having to replace a battery. That just strikes me as remarkable.
Yeah, even the cell phones and everything. We don't have to plug it and charge it every time. Laptops and all those things.
You know, they have these little lithium batteries
Mm-hmm.
in the computers. When they run out, the computers just kind of die.
Yes.
And you can have a supercapacitor in there, just keep it charged all the time. You wouldn't even need electricity.
Yeah.
Anytime you plug it in, you just have your battery
Yes.
topped off.
Yes. So coming to the advantages, we can reduce the use of plastic. That's like the it's a minute quantity, but still the plastic takes so many decades to degrade. So I think it's we can reduce the usage of the plastic that's wrapped around the wires. And also yeah, here the point is the need for the batteries becomes reduced. And the installation of any equipment which needs like a lot of wires, where we use a um, uh, o- the box where we plug in like 10 different kind of plugs, so the installation becomes very simple and easy. So these are all the like the advantages that come up with using the Vitricity concept. And coming to the market, I think because this we use electricity everywhere in the world, like so everything can be changed. All the this is a very broad range of market because electricity and the power is used everywhere. So we can um, change using the using the wires with the fractal antennas for transmitting the power. So I think it has a very broad range of market.
Any questions? So, sustainable competitive advantage. Do you think maybe you could get a patent out of it?
Yes, there's no there is no I
No
checked in the
electricity-based fractal antenna
No,
patents. Has it appeared in literature before? Electricity-based
using
fractals?
a microstrip patch antenna. There was one, but um,
So you'd have to have a different refinement or improvement patent.
yes, I mean I'm not using the frequency or the parameters which he is using. I use a different.
Maybe this could be designed for very low power biomedical devices where you don't want
Yes.
to make a physical connection.
Yes, we can. Yeah,
Great.
thank you.
You know what I'd like to do here is, let's just take a little break. I'll stop it and then restart it.